Hello everyone, we are from Group 5 Section 9 Introduction to Electrical Engineering. Today we will talk about our project, and the title of our project is Quarantine Zone Specialized Personal Level Transportation Intelligent Robot. So first we will talk about the introduction. So for the introduction, we will talk about the project background. So for now, as we know, we are still in the midst of the coronavirus pandemic, and it's bring many inconvenience to us. So the coronavirus is first found in Wuhan and then spread worldwide. If you are infected by the coronavirus, then you will have fever or loss of taste, and severe case you may cough death. So to control the outbreak, Malaysian government has implemented the MCO. And however, until December 16, 2023, there are still 5 million of confirmed cases and 300,000 of deaths. And for the quarantine zone specialized personal level transportation intelligent robot is to reduce the probability of the coronavirus transmission. And this project also achieved the SDGs, the Sustainable Development Goals. So for now, the problem statement is until December 16, 2023, there is 5 million confirmed cases, and these cases is very worrying the people. So that's why we will do this project about the quarantine zone specialized personal level transportation intelligent robot. So then our objective of the project is to reduce the probability of coronavirus transmission, reduce human-to-human contact, and provide efficient, safe, and autonomous work. So the scope is to achieve the intelligent usage of quarantine zone intelligent robot. Then we have introduced the Raspberry Pi 4i as the main control chips, and the intelligent robot also feature an integration module, navigation and mobility, and alpha. So the next we'll talk about the literature review.
First we start from the main control chip, and we use a Raspberry Pi 4 as our control chip. It is a powerful single-board computer suitable for network connection, sensor data processing, display driving. And the key features include a quad-core processor, 4GB RAM, multiple USB ports, HDMI output, dual-band Wi-Fi, and support for various operating systems. And we also use touch displays under the Raspberry Pi. And this is the speaker that we use. This is for control the speaker. And in the navigation and maneuvering, this is Intel RealSense Depth Camera D435, and this is an ultrasonic sensor that we use. This is the LiDAR we use, and this is the IMU we use. In the driving module, the Maytag 6374 170 kV sensor brushless motor will be used, and this is the controller for the motor. And this is the wheels we use, which is an omnidirectional wheels. And for the storage bin status management, this is the photoresistor we will use, and the lock, which is a electromagnetic lock, and the UV lamp for sterilize. And for power supply, 24 watt 30 Ah LiFe PO4 battery designed for robotic system, offering a long service life, high safety and environmental friendliness.
Okay, right now I will talk about the methodology. And the first step that we do in the methodology is the planning and research. The planning process is the critical step in the project where team members are required to brainstorm and deliver a project plan that meets the client's requirements. This process is designed to achieve the project goals and therefore requires each team members to update the program of their own on weekly basis. In addition to planning, a series of research is conducted to ensure the accuracy of the project. The research process includes reading a variety of materials such as articles, reports, and websites. And at the beginning of the project, each team members will do a research and read the information related to this project. And afterward, the team members will discuss and gather the information to create a design solution that is easy to understand. And after we doing the planning and research, we managed to do a flowchart during this process. And the start will, of course, the start of the project and clarify what is the problem statement that we will do. And next, we will have the research on literature review. And the next one will be say that does the research is enough? If yes, we'll go into the next step. If not, we'll doing the research again. And after this, we'll draft the design the product. After this, we're making the 3D model and refine the project again. And does the refinement is enough? For is yes, we'll go into next steps. And the last two steps is calculating costing, target price, and also the conclusion. And after this, we'll talk about the conception design. Conception design is the design process in the early stage of the project. It outlines the functional outline and form the product. The four design phases are product definition, conception design, embodiment design, and detail design. The conception design will allow the clients and team to understand the product and give team members a detailed understanding of this product. And conception design will also provide a framework of continuous improvement throughout the project, and multiple designs may emerge. The sketch and model are common conception design artifacts, and by comparing each design, the team member can more easily select the best design. The main goal of the conceptual design is to create and find a design that will produce the best quality of the product. And therefore, we can create a flowchart of this. The first one will be delivered multiple design. And after this, we'll compare this design and eliminate the pro design. And after this, once the best design is chosen, we'll deliver the design selected and perform it in a more detailed sketches. And after this, we'll talk about the total cost that we will make this project. And after all the sum, the total cost which will be 10,112 ringgit. And after this, we'll conclude the target prices, which is 550,000 ringgit. And the target market for this project will be the hospitality industry, such as hotel and hospital.
So design stage is basically a design and its process to discuss and develop the approved concept design. And our project module is sketched by the Tinkercad, which is free online app for TT Design. So in our first stage, the design is inspired by the intelligent food service robot in restaurant. Next, in our second design, the stretch is maintained, but the weight is decreased to make sure there is enough for the robot and people to pass by. Mapping and route planning system is one of the functions for our robot. Here is how it works. In the beginning stage, the robot needs to be driven by a technician to work on mapping the environment and routes in the building. The team work with the building owners to determine the robot delivery point, usually based on the room number. This is so that the robot can be programmed to carry food and items. All corners and ramps are uploaded to the system cloud platform. Maps are saved in the robot memory, and built-in software trains the robot how to move and navigate to its destination. When two robots cross paths, they will communicate and pause or redirect as needed to ensure they reach their final destination. When the robot successfully deliver an item, it alerts the customer through a series program stage, such as please hold your item and thank you. So the next function of our robots is the interaction of intelligent robot with elevator control system. So this function is important because our intelligent robot is an automated robot that is primarily used to transport items or food in quarantine buildings. This requires the robot to understand and determine the target location. The robot navigates to a specific location in the building elevator lobby using advanced positioning and obstacle avoidance technology to ensure safe navigation. In order to use an elevator, the robot needs to communicate with the building's elevator control system to send a command to call the elevator. Upon receiving the command, the elevator control system simulates pressing the button for the appropriate floor and sends a message to the robot. Once the robot enters the elevator control system starts the elevator and moves to the floor selected by the user. Upon reaching the target floor, the robot needs to replan its path and navigate to the user's specified destination. This is achieved using map switching and path planning algorithms. Next. For the discussion part, we will discuss the relationship between the Sustainable Development Goals (SDGs) and Quarantine Zone Specialized Personal Level Transportation Intelligent Robots. So, for your information, the Sustainable Development Goals are called by the United Nations, adopted in 2015, to eradicate poverty, protect the planet, and ensure peace and prosperity for all by 2013. During the COVID-19 pandemic, there is a need for a sustainable revolution to bring about change in societies on the brink of crisis. And some of the goals include responsible consumption and production and building partnership to achieve the development goals. So this is the 17 goals are provided in the SDGs. The first, sustainable consumption and production, is the 12th goal of the Sustainable Development Goals, which aim to ensure sustainable consumption and production patterns, improve resource and energy efficiency, build sustainable infrastructure, and provide access to basic service, green and decent jobs, and better quality of life for all. This is similar to the concept of this project, which is create and reusable products that reduce waste and cost while reducing the carbon footprint. So the next one is the third goal, which is good health and well-being, aim to ensure healthy lives and promote well-being for people of all age. Our transportation smart robots are technology that encourage healthy lifestyle and help prevent human contacts and disseminates information on epidemic prevention and control. So the third one is the ninth goal, which is industry, innovation, and infrastructure, which include the development of high-quality, reliable, sustainable, and resilient infrastructure to support economic development and human well-being. One of the goals of this project is to build transportation smart robots is to improve the quality of hospitality infrastructure to provide fast and safe service to customers and reduce the risk of the epidemic spread. In summary, responsible consumption and production, good health and well-being, and the development of industry, innovation, and infrastructure are important components of the Sustainable Development Goals. The project achieves this goal through the creation of reusable products, the use of quarantine zone specialized personal level transportation intelligent robots to promote healthy lifestyle, and the provision of high-quality infrastructure. This will help to promote sustainable development, reduce resource waste, and protect the environment and improve human well-being. At the same time, this initiative will help to prevent and control epidemics and ensure the safety and health of people. The next one is the relationship between ethics and quarantine zone specialized personal level transportation intelligent robots. To ensure that the project is safe to use, the team conducts detailed tests and thoroughly researches the hazards and risks that could be posed to the customer and eliminate any factor that could cause harm to the customer. The project was created by a team of electrical engineering students who are pursuing a postgraduate study with the aim of becoming expert in the electrical and electronic field. The project was supervised by Dr. Muhammad Fairuz bin Muhammad Yusuf, Associate Professor at the Faculty of Electrical Engineering. The team members put a lot of effort to ensure that the project meets the standard and accepted in the market. The final report statements or tests are original and truthful to avoid deceptive behavior. The conclusion of the quarantine zone specialized personal level transportation intelligent robot project are based solely on the actual product completion process.
Okay, now we go to conclusion. The paper describes a study of a project on intelligent robots for personal transformation specific to quarantine zones. The goal of the project is to reduce the risk of spreading COVID-19 outbreak and to address the key issues between people in the quarantine zone by reducing human contact. The robot was designed with advanced features such as Inter-Rail Sense, depth camera navigation, and Raspberry Pi 4, demonstrating a deep understanding of the project's goals. Also, the project succeeded in achieving 3 of the UN's Sustainable Development Goals: health and well-being, industrial innovation, and infrastructure and responsible consumption and production. Now, in the methodology section, the team details a research approach which included planning, research, conceptual design, and phase development. They also ensured the economic viability of the project through a total cost analysis and emphasized the utility and applicability of robotics in areas such as hospitality industry. Overall, the project not only meets the broader sustainable development goals, but also addresses the pressing issues posed by the COVID-19 pandemic by focusing on the key objectives of reducing human interaction, reducing viral transmission, and providing fast, safe, and autonomous transportation. The project responds to the UN's call for global action. Plan for future plan. From the scenario of the Malaysia's technological level, it is hoped that this project will be common applied to our society, not even the hotel, but also every place such as restaurants, canteen, house, and others. We also hope that we will have more cooperation with relevant authorities for a higher quality of innovation and improvement through the project. Based on this project, the main objectives of the future project is to decrease the cost and price of this product. Also, with the aid of the new technology, the parts can be produced on a smaller scale, and thus we can decrease the size of the product by maintaining all the functionality of the product.